All right, here we go. Solve cosine of 2x equals 1 minus sine of x. And obviously we're solving for x here, and x is between 0 and 2 pi. So how are we going to do this? And hopefully looking back at those scenarios, you can see that this is going to be scenario 1, that we have a double angle in here. However, there's also just an x. So we need to use our identities to change this cosine of 2x into an x that we can then work our way through and solve. So cosine of 2x, what are we going to do first? Well, rewriting that, we've got a few different ways to rewrite cosine of 2x. Sorry, it's kind of ugly. Cosine of 2x. And it's equal to all three of these things. First, it's equal to cosine squared of x minus sine squared of x. And that way, at least we'd have things in terms of x. However, we don't have, we have just sine on the one side. So if there's one that we could change everything to just sine, that might be more convenient for us. And so you can work your way through. If you have those other ones memorized, you can plug them right in. I'm going to just go through and assume that we don't have that memorized, that this is the only one that I have memorized at this point. And if you do have it memorized, you'll be able to use that as a shortcut. But if not, then you know at least that cosine squared of x minus sine squared of x equals 1 minus sine of x. And now looking at this, we got all this sine but one term of cosine. However, it's cosine squared, and we kind of, hey, wait a second, I know how to deal with that. What are we going to do with cosine squared? Well, remember, sine squared plus cosine squared equals 1. So if we subtract sine squared from each side, we have cosine squared, cosine squared equals 1 minus sine squared. And we can substitute that in, and then we'll have just sine, and we'll be able to kind of work our way from there. So then, we have 1 minus sine squared x, just substituting that in for cosine squared of x, minus sine squared x equals 1 minus sine of x. All right, let's subtract 1 from each side and combine our like terms. So hopefully this doesn't go too fast right here. We're going to have negative 2 sine squared of x equals negative sine of x. So all we did was we subtracted 1 from each side and combined our like terms right here. All right, from here, what can we do? Well, we can factor out a, let's add 2 times the sine squared of x to both sides. And we are going to get, that's going to be 0 equals 2 times the sine squared of x plus, minus minus sine of x. You can factor out a sine squared of x, and so we have 0 equals sine of x times 2 sine of x minus 1. And now we've got it in factored form, and hopefully from here you're comfortable with what we're going to do. We're going to split this into the two different things that our factors can be equal to. 0 can either be equal to sine of x, that's part 1. And then we're also going to set 0 equal to 2 sine of x minus 1. All right, where does sine of x equal 0? And that's going to be at both 0 and pi, so x equals 0 and pi. Over here, we're going to add 1 to both sides, and we'll have 1 equals 2 sine of x. Divide each side by 2, so that's 1/2 equals sine of x. And where does sine of x equal 1/2? Well, that's going to be, we'll erase it in just a moment, but let's sketch out our triangles here. So where is sine going to be equal to 1/2? right there and right here, and that's when this is we're dealing with radians, so this is going to be pi over 6, and then when this reference angle is pi over 6, meaning that the angle itself is 5/6 pi. All right, so x equals pi over 6 and 5 pi over 6, and there's our answer. So writing those all together, let me just box them up. There's our answers. All right. Actually, we're going to go ahead and stop that there and continue on the next one in the next video.